Alright. We're going to Alright, let's see what we have. Anyone can access deleted and private repository data on GitHub. So first of all, I have two questions. This is pretty bad, but anyways, we're gonna go one take on this. Okay, let's go like this, maybe. Can access data from deleted forks, deleted repositories, and even private repositories on GitHub, and it is available forever. This is known by GitHub and intentionally designed that way. It is such an enormous attack vector for all organizations that use GitHub. We are introducing new term, cross-fork object reference, CFOR. Okay, let's see. Okay. Okay. Maybe I Alright. Consider accessing deleted. Yeah, I can't. It's just too bad. Yeah, okay. Have the monitoring off. I don't think we need that. Anyways, consider this common workflow on GitHub. You fork your public repository, you commit code to your fork, you delete your fork. Okay, sure. Adding a new feature, browse, delete this repository. Is the code you committed to the fork still accessible? It shouldn't be, right? You deleted it. It is, and it's accessible forever, out of control. In this video below you'll see, is the code you committed to the fork still accessible? Oh, so maybe you can just fork something and then, like at the beginning of a GitHub repo that's initiated, and then, okay, let's not have assumptions. It is, let's just make this bigger. In the video below you'll see a us fork repository, commit data to it, delete the fork, and then access the deleted commit data via the original. See us fork repository, commit data to it. So okay, now I think you're protected by needing to know the commit hash or not the hash is discovered. More on that later. How often can we find data from deleted forks? Pretty often. We serve with a few letter 3 colon fork public repository from large AI company easily found 4D package from deleted fork. These essentially this fork the repo hard code time do work delete. Alright. So what do these guys have here? They have some outputs, they have source, they have this, that, and then now we have consider the scenario. You have a public repo on GitHub. A user forks your repo. You commit data after they fork it. You have a public repo. After they fork it, they never send the forward your update. Delete the entire repo. It's the code you committed after they forked. Yes, GitHub stores repositories and forks in the repository network, with the original upstream repository acting as the root node. When a public upstream repository that has been forked is deleted, GitHub reassigns the root node role to one of the downstream forks. However, all of the commits from the upstream repository still exist and are accessible via any fork. Alright, GitHub has repository network. Simple your forks, these are your comments. The upstream forks. I mean, kind of makes sense. Like forking is like having your own copy of that repo, right? So that kind of makes sense. Since some weird edge case scenario, some full elastic submitted a P1 vulnerability to a major tech company showing the exact private key for an employee's GitHub account that had significant access to the entire GitHub origins. They immediately deleted the process, but since it had been forked, it could still access the commit containing the sensitive data while forked, despite the fork never syncing with the original upstream repository. This here is that any commit may be accessible forever as long as there is at least one fork of that. It gets worse. Accessing private repo data. Consider this common workflow for open sourcing a new tool on GitHub. You create a private repo that will eventually be made public. You create a private internal version of that repo and commit traditional code for features that you are not going to make public. You make your upstream repository public and keep your fork private. As your private features and related code by the public, yes, any code can between the time you create an internal for a tool and you open source the tool. These comments are accessible to the public, and the comments made to your private fork after you make those not viewable. That's because changing the visibility of private upstream repository results in two: one for the private version and one for the public version. In the video below, we demonstrate how organization open source new tools while maintaining private internal forks, then show how someone could access commit data from the private internal version via wait, I didn't get the last bit. Listen to comment. Destructive actions in GitHub repository network, like the three scenarios mentioned above, remove references to commit data from the standard GitHub UI and normal GitHub. However, this data still exists. It's still accessible if you know the commit hash. This is the time between CFOR and IDOR. This is why okay, perfect. See, okay. Okay, so cross fork. Oh no. Cross fork object reference. What is this? CFOR. Okay, that's something. To actually, so basically create a new repo. Got that repo. Did he fork from it? I'm not sure. We sent similar findings to GitHub via their VTP program. This was their response. Thank you for saying this is an intentional design decision is working as success and in this pull request collaborating forks. What happens to forks and requests and changing your private repository. Okay. Alright. Change private and all the comments in different including instead each private fork becomes separate private repository. So independent network. Okay, we appreciate this. This is average user. Okay, yeah, maybe I should read it. When you change a private repository to public, all the comments in that repository, including any comments made in the repositories, was forked into will be visible to everyone. However, the private forks will not automatically become public. Instead, each private fork will become a separate private repository and create its own independent network of repositories. Any new change made to this network will not be accessible from original repositories. Okay, so this is what they said. Kind of makes sense. So if you have a repo that's private initially, so you take it public and then you take it private, but if someone has a fork from it, kind of makes sense. Like you have a copy of what was public, but do you have more copies after the comments are pushed in the private zone, in the second private part? So it goes private, public, private. In the second one, you have fork. I did not get that, but let's continue. We have a few takeaways from this. As long as one fork exists, any comment to the repository comments on the transfer will. Okay, I'm gonna going to work on upstream, downstream. This feature comment Siemens argued that the only way to securely immediately key on repository is through key rotation. We spent a lot of time documenting how to rotate keys for the most popularly leaked secret types. Check our work maybe later. GitHub repositories architecture necessities these design flaws, and unfortunately the vast majority of GitHub users will never understand how the repository network actually works. That includes me, and will be less secure because of it. As secret scanning evolves and we can hopefully scan all commits in the repository network, we'll be alerting on secrets that might not be our own. Excuse me. They might belong to someone who forked the repository. This will require more diligent triaging. While these three scenarios are shocking, that doesn't even cover all of the ways GitHub could be storing detailed data from your repository. Check out your recent posts related how you also. Okay, Okay, let's go from the top again. Go step by step. Let's Google this. What is upstream and get? Okay. The term upstream and downstream refers to the repository generated upstream is where you clone the repository, and downstream is any project that integrates your work with other works. However, these terms are not restricted to Git repositories. Thanks for that. In terms of source control, you're downstream when you copy. This kind of makes sense. From repository, information flow downstream too. When you make changes, you usually want to send them back upstream so they make it into the repository so that everyone pulling from the same source is working with all the same changes. This is mostly a social issue of how everyone can coordinate their work rather than a technical requirement of source control. You want to get your changes into the main project so you're not tracking divergent lines of development. Sometimes you read about prior package or release managers, the people, not the tool, talking about submitting changes to upstream. The issue is they had to adjust the original sources so they could create a package for the system. They don't want to keep making those changes, so if they send them upstream to the original source, they shouldn't have to deal with the same issue in the next release. Okay. The issue means they had to adjust the original source so they could create. What does that mean, Chad? What does that mean? What does that mean? You're pushing to upstream. Okay. Basically, source clone, we push up to the upstream because we are downstream. Alright, that isn't that bad. Delete your fork, and the code you committed to the fork is the code you committed to the fork. Shouldn't be, right? You delete it is, and it is accessible forever, out of your control. The view below you see as fork repository comment data to delete the fork and access the deleted comment. Oh, okay. Interesting.